In this lab, management wants us to create ether channels between switches on the first and second floor. Specifically, management wants an ether channel between switch 1 and switch 2 using interfaces FA0/11 through FA0/13 on the first floor, and management wants an ether channel between switch 1 and switch 2 using interface FA0/11 through 18 on the second floor. So, what exactly is an ether channel? Ether channels are groups of multiple physical Ethernet links that are grouped into one logical link between switches. Why would we do this? By combining the links into one, we get a few benefits. The first benefit is that the link gets more bandwidth. So let's say we had 3 fast Ethernet links that can reach 100 megabits per second. Then by combining them into an ether channel, we then get one 300 megabit per second link between the two switches. The second benefit is that the data traffic is balanced across the 3 links. Essentially, the traffic is spread evenly across all links in the channel. So this is called load balancing. If one link fails and drops, the remaining 2 links adjust to evenly carry the traffic. This way, an outage doesn't affect bandwidth as drastically. Traffic is quickly balanced across the working links. So, load balancing distributes network traffic efficiently for optimal usage. It's one of the major benefits of ether channel technology. So, in summary, ether channeling combines multiple switch links into one logical link, provides more bandwidth, redundancy, and efficient load balancing, improves network speed, reliability, and resilience. Okay, let's start with switch 1. Management already has the physical links attached, so we just need to group them logically through some configurations. So let's console into the switch with PC1. Now, let's see which lines are the ones that management has already connected for us between the two switches, with the show interface status command in privileged exec mode. It appears FA0/11 through 13 are the 3 connected to the other switch. We can confirm this with the show CDP neighbors command. Okay, first we need to enter port channel configuration mode. We do this by entering interface port channel 1, with the 1 representing the ID of this port channel group. Then, let's make this port channel a trunk since it'll be connecting 2 switches to one another. Now we have to apply the port channel and trunk settings to the interfaces that we're grouping together. Let's do this by entering configuration mode of all 3 interfaces with the interface range FA0/11 through 13 command. Now let's put in switch port mode trunk to make these interfaces a trunk port. Then we'll want to assign the ether channel group 1 we created to these interfaces with the channel-group 1 mode active command. The channel-group 1 portion of the command means we're grouping these interfaces into port channel 1. The mode active portion of the command means the mode is active, as in it will use the Link Aggregation Control Protocol, or LACP, to actively negotiate grouping with the other device, which in this case is switch 2. The LACP protocol controls how links combine to form an ether channel. LACP uses messages between the devices to negotiate the grouping so both sides of the Ethernet channel links, switch 1 and switch 2's interfaces in this instance, agree on the link configurations. The other channel group mode options include Auto, which uses Port Aggregation Protocol, or PAGP, which is Cisco's version of LACP. That means it would work if you were connecting only Cisco switches with one another. And Auto will only negotiate if it's connected to another PAGP interface on another switch. Meaning, the switch that has Auto is waiting for the other switch to send some PAGP frames. Desirable is like the PAGP version of active, where it will actively try to negotiate the ether channel. On just bundles the links without any protocol like LACP or PAGP. Think of it like a static trunk. And passive is like auto, but for LACP, where it will only negotiate if the other switch has LACP enabled. So why use LACP protocols? It's good for cross-vendor compatibility, meaning you could connect, for example, a Cisco switch to a Juniper switch. Why use PAGP? If your whole network only uses Cisco switches, you could stick to PAGP. How about the static on mode? Why use that one? You'd use it if you just need a fast static bundling on a Cisco switch and you don't care that it doesn't check or respond to configuration changes on either side of the link, as in switch 1 or switch 2's interfaces. The other protocols negotiate and try to make sure both switches and sides match, but on mode will just not work if they don't match. Okay, save your configuration. Since we did one side of the link using LACP's active mode, now let's move the console cable and jump into switch 2 to configure that side of the link. We could see with the show interface status command that the linked ports are FA0/11 through 13 on this switch also. Let's create our port channel group with the interface port channel 1 command. Then we'll apply the switch port mode trunk command. Next, let's apply the port channel group to the correct interfaces with the interface range FA0/11 through 13, and then switch port mode trunk, and then channel group 1 mode active. Notice the logs that appear when you put in those commands. The last two lines show that port channel 1 changed its state to up. Let's verify the port channel settings. We can start with the show run command. The show run command lets us see the port channel 1 interface that we created, and the channel group 1 commands we place on the interfaces that we grouped together. The show EtherChannel summary command lets us see the port channels in use, the protocol used, and the ports of the port channel that create the EtherChannel group. Notice that the SU next to PO1 means it's a layer 2 port channel that's in use. The show interface port channel 1 command gives us detailed information about the port channel. Notice it states that the port channel 1 is up and the line protocol is up. Port channel is up refers to the physical ports bundled to form the logical interface being operational. Line protocols up refers to the protocols managing and using that logical interface being good to go. It also states that the bandwidth is 300 megabits per second, which is because the three 100 megabits per second interfaces were combined. Also, notice it says we're only working at half duplex. What the heck does that mean? Half duplex means traffic can only flow in one direction at a time, like a walkie-talkie. One way, and then the other. This limits the bandwidth. In the real world, this should be full duplex, which would allow traffic to flow in both directions at the same time, like a phone call. The show EtherChannel port channel command also gives us another view of the port channel information. And also, the show IP interface brief and show interface status commands now also include our port channel 1 as an interface, so we can check its status in these two views as well. Make sure to save your configuration, save your packet tracer lab, and update your notes. Now we're going to move on to the second floor switches. Remember first, we check which interfaces were ether channeling together. Looks like the 8 interfaces are these ones that are administratively down at the moment, FA0/11 through 18. Okay, now let's create our port channel. And then assign a trunk and a port channel to the interfaces. Remember, the interfaces are shut down administratively, so we'll want to do a no shut on them. Notice how they all come up on the logs. Now, let's save the configuration. We just have to repeat the process on switch 2 of the second floor, this time to complete the port channel. First, checking the interfaces, which appears to be the same FA0/11 through 18. Then we create the port channel interface. And finally, group the interfaces together by assigning them as trunk ports and then grouping them with port channel 1's channel group. Now let's verify the port channel with the show EtherChannel summary command. Awesome. Now save your configuration, save your packet tracer file, and update your notes. Then create your narrative. After that, share the Google Drive folder you have for this lab with anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.